now we're going to be talking about quadrilaterals, determining if they are parallelograms or not. There will be some proofs. You might have some pictures that look like parallelograms, but you'll have to decide if there's enough information to give you to determine it. This is the third section for chapters or unit 6. All right, so here are the ways we're going to use to prove. We're going to do that. There are 5 ways to prove that a quadrilateral is a parallelogram. We're going to do that by looking at some of your postulates and theorems on your, we're going to look at those odd ones that we weren't looking at last time. There's one even one, by the way, though. There's 3, 5, 7, 9, and then one little lone one out there at 10, okay? That means I think we've covered all 10 so far. First 10 out of the 18 that there are. All right, number 3. We'll just start our way over here and work our way around. Number 3. Heidi, if you'll read number 3 for me.
Well, if both pairs of opposite sides of a quadrilateral
Good job.
are congruent, then the quadrilateral is a parallelogram.
Very good. This is a converse. It says converse to the parallelogram opposite sides theorem. So this says that if you have a quadrilateral with the opposite sides congruent, then it's a parallelogram. Let's go over here to Amy. Let's do number 5.
Converse of the parallelogram opposite angles theorem. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram.
Last section we said that if it's a parallelogram, then the opposite angles are congruent. Now we're saying if you have a quadrilateral and opposite angles are congruent, then it's a parallelogram. Josie, will you read number 7 to me?
If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram.
Very good. Let's talk about that one. This one has a little bit different connotation. Let's get this out here. I'm going to draw a parallelogram. Okay. The consecutive angles, if I'm going to name that one again, A, B, C, and D. That one must be supplementary to both D and B before we can call it a parallelogram. So if I have a quadrilateral and I know that one is, that's A, one of them is supplementary to both of its consecutives, then automatically it is a parallelogram.
Would that diagram right there tell you that they're supplementary?
Yes. No, it would not.
Okay,
I would have to say something like, I would have to say like 30 and 150 and 150 or something like that, so you could say that those
would be part of the given.
Something
that,
yes.
A is supplementary
to
D, and D and B are congruent.
Something like that, yes. Yes. Okay. All right. Number 9. Let's do number 9. We're over here. Brett, we're with you. Number 9. If you'll read it for me.
If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram.
Very good. We had that one last time. If the diagonals bisect each other, if it's a parallelogram, then the diagonals bisect each other. Now we're going backwards and saying that if they do bisect each other, then it's a parallelogram. Last one, number 10. This is a brand new one.
If one pair of opposite sides of a quadrilateral are congruent and parallel, then it is a parallelogram.
If I were you, when I put this one into my postulate book, I would draw this one. I'm going to draw a parallelogram. We had 4 of them previously, and we've done the converses of all 4 of those from last section, but this is a brand new one. This says that if we have opposite sides are congruent and parallel, not both pair, just one of them. So if I had these 2 are congruent and parallel,
then
everything else works out.
Yeah.
Okay? I don't have to have any more congruence. I just have 2 pairs of opposite sides congruent and parallel, and then it's a parallelogram. This is the only one that doesn't have the word converse in front of it. All the rest of those 3, 5, 7, and 9 had the word converse in front of it. Opposite sides if the opposite sides are congruent, we just learned that one, right? Yeah. We also learned about the opposite angles congruent. You learned about consecutive angles supplementary. Be careful, that's not all of the consecutive angles. That's just one of them is supplementary to its 2 consecutive. we had the diagonals bisect each other, and here's the last one. Opposite sides are congruent and parallel. We're going to put all those into this, okay? Now, the cool thing is we won't have to write them all down. We won't have to write them all down because these ones we've already written, all we have to know is the converses of those. So, we'll use the converses of these above to prove parallelograms, so we don't have to write them all out.
So just say converse of above.
So I just said we use the converse of the above to prove a parallelogram. There's one more after that. The only one that was new that didn't have the word converse. This is for proving. You might even, if you want to, put the word prove right in here. If you wanted to. So below that would everything that proves
For the parallel.
proves the parallelogram. You can put that. Your guys likely have more room than me.
So this is like in earlier chapters when we had to prove it was like parallel.
Yeah, we had to. Yes, exactly. We had to prove. If we knew they were parallel, then we had know certain things about it. But if we knew certain things about it, then we could prove parallel. So that's exactly what this is. We just learned these top ones are if we're told that it's a parallelogram, then we know this is true. The stuff at the bottom is you have to know that these things are true before it is a parallelogram. Okay, exactly like we did with the parallel before. That's yes. The last one on this one, all the converses of these above plus that extra one where one pair of opposite sides are both congruent and parallel. So 6.2, they told you had a parallelogram. 6.3, they're going to ask you, is this a parallelogram?
Oh, okay.
All right? One of them they told you had a parallelogram. This one you have to decide if it is a parallelogram.
Using those.
Using these reasons above here and one extra. Okay?
Got it.
All right. Let's do some examples so you can see what we're talking about. Oh, wait, I'm sorry. This is on your 6.3, numbers 1, 2, and 3 we're going to do together. 1, 2, and 3. Are you given enough information to determine whether this quadrilateral is a parallelogram? You cannot look at if it looks like a parallelogram. You have to go by the information that is given. Number 1.
Wait.
So based on what you wrote down, we had 5 things. Opposite sides are congruent. Opposite angles congruent. Consecutive angles supplementary. Diagonals bisect each other. So I just said opposite sides, opposite angles, diagonals, consecutive angles. There was that last one. What's the last one?
The one pair congruent and parallel, so yes.
So yes, this says that we have the congruent and parallel. It doesn't just say to write a yes or no. It says to explain.
What?
So we need to put the word yes, but which of the theorems says it? Was there a name to it? Was there a name to that theorem?
No.
There wasn't. So what was?
We have to read the whole thing.
Pretty close. What does it say? Someone read it to me so I'll see it. I'm going to borrow this one back. It said.
It's about the number.
Oh no. Because when you get to college, it'll be a different number. It says if one pair of opposite sides, so we have one pair.
Wait. What?
Opposite sides congruent and parallel. So we did pretty good. Look at that. Brett's writing more than me. Look at that.
Which one is that?
Oh.
After all that. One pair opposite sides congruent and parallel.
Oh.
Oh my goodness.
This is the only one that does not have the converse word in front of it. Okay? Number 2, do we have enough information for that to be a parallelogram? I heard yes, I heard no.
Yes,
Yeah.
we do.
Okay, so what's the reason if you say yes? The reasons
We
were...
have the vertical ones.
Converse of parallel
Diagonals theorem.
Yes.
Yep.
Converse, so this is a yes. Converse,
Can't we just put, we can put, okay.
yes. Just there's a title for this one, right?
Yeah.
Diagonal, what is it? Diagonals bisect theorem?
Converse parallelogram diagonals theorem.
Parallelogram.
Say that again.
Converse parallelogram diagonals theorem.
Okay, got it.
Is there enough information for this to be a parallelogram? Yes or no?
Yeah.
I heard a yes.
think.
This is uncomfortable.
What is it? I know it's going to be a converse because it's not one of those parallel and.
That's right.
Okay, I got my N right.
Consecutive angles theorem?
Not consecutive angles.
Not
No,
that.
because opposite angles.
Opposite
No.
angles,
No.
opposite
Opposite sides.
sides. I'm going to do it capital M. Oops, I'm sorry. No, I'm not going to.
I swear.
Okay, questions?
Wait, do we not have to put the word parallelogram in them because the
I don't
definitions
care if
on
you
the
go-
other side say the word
Oh, converse,
converse
opposite.
parallelogram opposite.
Oh, okay, I could. We're going to do numbers 7 and 8 only. I couldn't cut it out very well because I needed the diagram. We're only doing 7 and 8. It says what additional information is needed in order to prove that the quadrilateral ABCD is a parallelogram. Notice how they went in order all the way around when they labeled it ABCD.
Oh, yes, it is.
They didn't jump around. All right, number 7. It says that AB is parallel to DC. They're saying right now that this is parallel to that.
So that we would need that AB is congruent to DC.
We could say
AB, yeah.
AB is congruent to DC. What other thing could we say if we didn't? Heidi?
A line BC is parallel to a line.
One more time. I agree, but I say the letters again.
Line BC is parallel to line DCA or AD.
AD. And in this case, you know how we had to list them in the right orders with triangles? Don't worry about that
Mom,
now.
that's AC, not AD.
What? Yeah.
D. So that would be saying that this one was parallel to that one, and that would make it a parallelogram by the definition of a parallelogram.
Yeah.
If we did the other one, we'd be using that one about
Uh,
opposite sides being both congruent
At least
and
they don't ask us to
parallel.
explain this time.
It did not ask us to explain.
Hallelujah.
Okay. Number 8. Are we ready for number 8? You could, and by the way, you didn't have to write both of these at number 7. You needed to write one or the other. I'm going to clear my drawing over here. Number 8. AB is congruent to DC. I have AB congruent to DC.
So we can do AD is congruent to BC, right?
AB. We could do AD, you said? Congruent to BC, yes. AD congruent to BC. Or
Line AB parallel to line DC.
yes. So we could say that AB parallel to DC. Oh man, I better fix it before I get in trouble. All right, it was BC. Okay. No, DC.
Is that okay?
Here we go. Questions about
There's
this?
no line behind that D.
Wait, when you wrote the other one on that last page that you just
Oh.
did, when you wrote the thing below this, was it just because you didn't have room for it?
Yes, because I
Okay.
didn't have room. That's right.
I was like, wait, did
It was
you
supposed to go with
just
8. I just didn't have room. That's correct.
Okay.
All right, we're going to do some plans for these proofs here. So I'm not doing the proof for you, but I'm going to give you the ideas of what to do. So I would suggest for everybody in this room who is having troubles with proofs, 'cause nobody in this room is perfect with proofs.
Ew.
Everybody can learn. We all need help with this. So I would suggest you write as much as you can about this so that you can get this done. All right. It says here that we have 2 triangles that are congruent. I am going to just make them in 2 different colors. Now they're telling us, now they're giving us 2 parallelograms. I'm going to highlight them. Here's a parallelogram. All right, so we've just marked those 2 parallelograms. They're sharing, almost looks like a parallelogram in there. We're trying to prove, I'm going to put dots on what we're proving. We're trying to prove that angle W equals angle U.
Whoa. Okay.
Okay? We're trying to prove that angle W equals angle U. And I did not mark them as such because I didn't want us to think that they were. We're trying to prove it. So let's ask some questions. What is angle W congruent to? That we know for sure.
Angle J.
So angle,
Oh, that's not too bad.
I'm going to put this in
and
red.
then J is to
Why is W and J congruent to each other?
Transit?
Transitive.
Yeah.
Why is W and J congruent? One more time. Why is W congruent?
Corresponding. No, not corresponding angles. Opposite
Yes.
angles.
Angle W is congruent to angle J because they're opposite.
Angles.
And there's a theorem that says it's the parallelogram opposite angles theorem.
I think so, yeah.
Correct.
Okay. It's the parallelogram opposite angles theorem. All right, now, where do we go now?
Same thing.
J to U.
J to U, is J and U congruent?
Yes.
Angle J is congruent to angle U. What reason?
Same reason.
Same reason. The parallelogram opposite angles theorem. How does all that help us?
Angle W congruent to angle U through transitive.
Very good. Right here we have U and J, W and J and U. So these two are in common. So we can just go straight to saying that W is congruent to angle U. Can't do that to go by transitive. Okay, that's your plan. We talked about this together. We got our plan. Okay. Please ask me a question if you don't understand something that I did, wrote, so forth.
Sound good.
Okay. All right. Here we go. A little bit more, not too much. We're only doing 3 of these, and then we're done. Okay? It's the next page over, I think, 14, 15, and 16. Maybe it's at the bottom of the page.
It's
I'm not
at the
sure.
bottom.
Okay.
For me.
All right. So we need to decide if they told us on number 14 that E was the midpoint of AC and BD. Would we have enough information for that to be a parallelogram?
Yes.
If E is the midpoint of AC and BD, yes or no?
Yes. Wait.
Yes.
Yes, because
That'd
we've got the
be
4.
diagonals bisect.
Yes. We do not have to write the reason, but the diagonals bisect is the correct one. All right. Next one. Now we forget what they said for 14 and we just concentrate on 15. ABC, which is right here, and BCD, which is right here. I'm not marking them congruent, by the way. I'm just marking them so that we can see where they are. It says that they add up to 180. Is that enough information to conclude that is it a parallelogram? I see somebody saying yes. I see somebody saying no. Which is it? Yes or no?
Yeah, well. Yes, because if that side's 180. Well, no, you have to know if the other side's 180.
Right here, number 6 on our postulates and theorems book, it says the consecutive angles of parallelogram are supplementary.
That's telling you that if it's a parallelogram, then they are. What's the converse, to
converse.
it? I marked off.
If an angle of a quadrilateral is supplementary to both of its consecutive angles, then
So
the quadrilateral.
So B has to be supplementary to both of its,
Oh, so no.
both C and A. So we have to have this one. We don't have that one. So this is no. This is why we talk about this together, so we get this before we move on, okay?
Oh, darn it, I lost my page.
Last one together. AB and DC are parallel. And BC and DA are congruent. Do we have enough information
No.
for that to say a yes or no?
No.
Why?
Because it has to be on the same side for those to matter.
Yes, to be able to be a parallelogram, the congruent and the parallel have to be together. So no, we do not have enough information. Okay? All right, questions?
We don't have to write the reasons on
We do not have to write the reasons, only write yes or no. Okay? All right, this is what we learned. We learned there are 5 ways to prove that the quadrilaterals are parallelograms. We learned that, now I want to explain something to you, so before you guys start putting all your stuff away, just a second. This week your assignments will be longer because we're studying for your final exam, so you will have more. Some of these, though, that very first one, you're just writing the words yes or no, or you might even be writing small words instead of lots of math problems. So, all right. Goodbye.